Hello and welcome to this Connect with Remedy webinar, where we're going to be looking at a number of different options for securing the connection between your AR servers and the databases that they use. My name is Mark Walters and I'm a support analyst at BMC, where I've been working with Remedy products for more than 15 years. In this webinar, we'll cover the steps necessary to configure encryption for AR servers using both Oracle and Microsoft SQL Server databases. Before we get into the details, we'll look at why you may want to consider using this feature and how it fits into the overall AR system architecture, as there are a number of different areas where encryption may be applied. There are some references at the end to online resources which provide more detailed information on the topics that we're going to cover. News of high-profile data security breaches are becoming increasingly frequent and are causing many organizations to think more carefully about what steps they can take to secure the data they own and manage. The consequences of a breach can have a severe impact on a business. In addition to the potential financial damage, both from the value of the data itself and possible penalties from regulators, there is a real risk to the reputation of the organization and the trust placed in it by those whose data they hold. Although many Remedy environments are maintained within organizations' own data centers, a significant proportion of breaches, more than 40% according to some reports, are the result of insider actions. About half of these are accidental and half intentional. Add to this that there is a move towards hosting these environments on third-party sites and in the cloud, and you can see that there are many reasons why taking advantage of all the security features a product offers should be considered. When thinking about a typical Remedy environment, there are several different areas where encryption may be used. First, there are links between browsers and mid-tiers. These can be secured using SSL, a feature that is enabled in the web server being used to host the mid-tier software. The mid-tier is itself a client of an AR system server and uses the AR API to communicate with that server. All supported AR versions include a standard encryption option that may be enabled by a server configuration change and will cause all clients to use a secured connection. Additional levels of encryption are available through the Performance and Premium encryption add-on products. The next layer is data traveling between the AR server and its database, and that's what we're going to be looking at in more detail in this webinar. The out-of-the-box configuration for all current versions of Remedy uses unencrypted connections to the database. Before version 9, the AR system server was written in the C programming language and used native database clients provided by the database vendor. Configuration of these clients to enable additional features such as encryption, for example, was done using the client software itself and was transparent to the AR system. Version 9 moved the platform to a Java codebase and started using JDBC drivers for database connectivity, which are included as part of the server package. This standard specifies the database connection parameters using what's called a JDBC connection string. The format of this string varies between databases, but the AR system builds it using values from the server ar.conf configuration file. The DB hostname, DB port, and several other options are read and used to construct the string, which is then used by the JDBC driver to establish the database connection. Prior to version 9.1 Service Pack 2, the connection string format was fixed, with no way to add the options that were used with the native clients to configure additional features. SP2 introduced two new AR.conf options, Oracle JDBC URL and DB custom conprops. The former allows for the connection string for Oracle databases to be explicitly provided. If this option is present in the AR.conf file, it overrides the standard format and the connection string derived from the standard settings is ignored. DB custom conprops is valid for both databases and provides a way to pass driver-specific options to the JDBC client software. The format of this option is a series of semicolon separated key and value pairs, and we'll see how this is used later in the webinar. The links provide details to some of the options that can be used with this setting for each database. As we take a look at how the database connections can be secured, one question you may have is how can we check whether the features have been enabled correctly? We're going to do this by using network packet capture software to snoop on the traffic passing between the AR system server and the database. How this is done will depend on the platform that's being used. These examples were captured on a Linux system using a program called TCP dump. In the videos later in this webinar, we use Windows systems and a program called Wireshark. The top capture shows data being sent to the database from an AR system server and clearly contains a select statement. The table and column names along with the query clause can be seen. The lower image is part of the response from the database. You may recognize the data. It's the user form record for Alan, a user that is included in the ITSM sample data. We can see the username, email address, group list, and assigned licenses. Once we've enabled encryption, we'll look at some of the captured packets to see how the data in them has changed. The first example we're going to look at in detail is Oracle's Native Encryption. This is a standard feature of the database software and the most straightforward to set up. We'll use a configuration tool on the database system to enable encryption and then restart the AR system server for the changes to take effect. We'll now switch to a video that shows the process and the use of Wireshark to capture traffic and confirm that we have successfully secured the connection. Before we start to look in detail at how to configure encryption, I'd like to just take a moment to show you the test setup that we're using for this webinar. So I have two Windows virtual machines. One hosts the Remedy server, it's 9.1 Service Pack 2, and the other virtual machine has both Oracle and SQL Server installed. At the moment, the system is set up to use the Oracle database, and we can see have a quick look at the system administration console and the server information. Confirms the version's 9102 and the database information we're using Oracle 12.1. Also on this system I have a tool called Wireshark, which is one of the many network packet capture utilities available, and I've got it configured to capture the traffic between the two virtual machines so that we can take a look at the data that's flowing backwards and forwards and see whether the data is actually being encrypted. At the moment, none of the encryption options are enabled, so anything that we do, we should be able to see at least some legible plain English text available in the data. So if I turn on the packet capture, after a few seconds we'll start to see some data recorded. That's background processing taking place by the server, so the server group checks, possibly escalations running. So I've paused the capture, and if we have a look at some of the packets, we may find, you can see that there is data in there that is recognizable and can be read. Not in all cases, there's still a fair amount of binary information that gets transferred backwards and forwards, but there certainly is some information that we can recognize. So if I re-enable the packet capture and then actually go and use the application, let's go and take a look at the groups form. Perform a search and select a few records. So that has caused data to be requested from the database. Pause the capture again, and we'll be interested probably in the larger size packets. So here we can see a select statement. Select check interval coordinator name from serve group config. So that's one of the background threads on the server performing the server group maintenance. So we can see there the select statement that was issued by the AR server to the database. And that's probably some of the information being returned. If we look further down the list, we should be able to find the group request that we did there. So if we try and read the text, placeholder group to allow assignment of submitter access. So that is placeholder group. So that we can see that this is an example of the data being returned from the database back to the server, and it's clearly being captured there. So the first thing, the first use case that we're going to have a look at is enabling Oracle's native encryption. Now this involves just some changes on the database server side, and we're going to use Oracle's Net Manager GUI. We're looking at the local profile, network security, and the encryption tab. So this is where we can configure the options. There are 4 different types of encryption level or encryption setting that we can enable. The default is accepted, which means that the database will honor a request from a client if it requests that encryption be enabled. Rejected, obviously the database will not accept encrypted connections. Requested, the database will request that the client will use encryption if capable, but will not enforce it, and then required, the client must encrypt connections, otherwise he will not be able to communicate with the database. We're going to change from accepted to requested. We need to enter an encryption seed, just some text, and we need to choose an encryption algorithm that we want to use. There are many available. Some are more secure than others. One thing to bear in mind, obviously the more complex the encryption algorithm, the more processing demands are going to be placed on both the server and the client, decoding and encoding the information. We'll just use the first one for the moment, and we'll save those changes. Back on the Remedy machine, at the moment the change hasn't taken effect. The settings are only enforced at the point at which a new connection is established to the database, and the way that the Remedy server works is once the threads are started and have their database connection, they maintain that until the process is shut down. So we're going to need to do a restart of the Remedy server. So we'll stop the server and restart it, and that will just take a few moments. So the database has restarted, and we can confirm that just by checking that we get a response from the mid-tier. So let's go back and restart the packet capture. Again, we should see some packets captured before we do any actual interaction directly with the client if we wait long enough, or we can just go ahead and select some of these groups. Let's stop and have a look. Now, one thing to note straight away is that the contents of the packets has changed. It now the contents are much more sort of random looking. No longer are we seeing any of the selects or the plain English text that was visible in the earlier example. So this is showing us that the data is now being encrypted as expected following the configuration changes. So that's the first example, and the most straightforward of the 3 that we're going to have a look at. There's one more thing I'd like to show you before we move on to the next example. On the Oracle side, we configured the database to use requested encryption. It's also possible, if we leave that now or set it to accepted, that we can use on the Remedy side, make a configuration change here to enable it on a per server basis. So one of the previously mentioned options that was added in Service Pack 2 was the DB custom conprops. That allows us to pass additional configuration options to the Oracle JDBC client or to any of the JDBC clients. If you look on the web, on the internet, look at Oracle's documentation, you'll find a set of pages that contain information about some of these options, particularly ones related to encryption, that show us how to set some of these additional parameters. So we can add an Oracle.net encryption client setting in the DB custom conprops to enable or to request that the JDBC driver enable encryption even though the database is only set to accept. So if we have a look at the ARCFG, I've already prepared the statement. We'll uncomment it, save the change, and again we need to restart the server for it to have any effect. So once this is restarted, we'll check again with Wireshark. We should still see that the encryption is enabled, but this time it'll be as a result of the client requesting it rather than the server. The server's restarted, so again we can use the browser just to confirm that, and then we'll go ahead and check the packet capture again. So back to Wireshark, stop and restart, and select the groups, go back, and we can see that the contents are still, as they were in the previous example, encrypted and not in any sort of plain text format. The next example we're going to take a look at is SSL with Oracle, but before we do that we'll just reset this back to the defaults so that we can be certain that no previous encryption settings are in effect. So that's the database side restored, and on the remedy side we will comment out DB custom comprops. And again we'll do a restart of the remedy service. The next example uses Oracle again, but this time with SSL. This has some additional features beyond the native client, such as authentication of clients and servers, but that's beyond the scope of this webinar. The process of configuring this feature is more complex, as we require an SSL certificate along with changes on both the database and AR system servers. We're also going to use the KeyTool utility that is part of a Java installation to make the certificate available to the AR system server, and we need to use the previously mentioned Oracle JDBC URL parameter to configure the encrypted connection. We're now going to take a look at what's required to enable SSL with Oracle. This is a little bit more involved than the Oracle native encryption that we previously had a look at. First of all, we'll just see and check that the database is no longer using an encrypted connection, and we've captured some packets here using Wireshark, and you can see their select statement and response from the database, including there some column headers. Lots of packets there, including recognizably English information, English data. So remedy's running again using an unencrypted connection. So first of all, we need to do some work on the database server. Oracle stores its certificates in a file called a wallet, or a set of files called a wallet. So we need to create a new wallet, add the certificate to the wallet, take the certificate and import it onto the remedy server machine, into the JRE, the Java instance that is being used to run remedy, and then we need to configure remedy to use the connection, use the encrypted connection. If you have access to a commercial certification authority, you can purchase a certificate. You may have a CA within your organization that create one for you, or you can use Oracle's own tools to create a simple self-signed certificate purely for testing purposes, and that's what we've done here. I'm not going to step through all of the details. If you want to read more about them, one of the Trending in Support blog articles that's referenced at the end of this webinar has the full details. So all of these steps have already been done. We've created a new wallet, which we can see in the DB wallet directory. I've created a self-signed certificate that's valid for a year, and we can list the contents of the certificate file, DBVM, so it's there ready for us to use, and I've already exported that certificate and copied it across to the remedy server machine. That's the first stage on the Oracle side. That's creating the wallet and adding the certificate. We also need to make some changes to the Oracle database configuration itself via the SQLnet.ora file to let Oracle know that there's a wallet file available and where to find it and what to use it for. So you need to edit the SQLnet.ora file, which is found generally in the network admin directory under the home directory of your database instance. And this is the information that we're adding. The SSL client authentication flag is set to false in this case. So this is telling the database that we're only using SSL for encryption. We don't want to use it for any kind of client authentication. It's an option that's available if that's something your organization wants to do, but it's a little bit beyond what we're going to go through in this webinar. We also need to specify the directory where the wallet is being stored and the fact that it's being stored as a file. So once all that information has been added, we need to restart the. We also need to make an addition to the listener configuration, so that the database knows where to listen for and where to accept encrypted connections, SSL-enabled connections, and that's done through the listener.ora file, which is also in the network admin directory. Similarly, we need to add the SSL client authentication and the wallet location details, but we also need to specify a port to be used by the SSL connection. So you'll notice the difference here. We're specifying TCPS rather than TCP, and we're using a different port number. It appears that 2484 is commonly used for SSL with Oracle, but it's by no means the only port that can be used. Any free port that you have is available for use. So we've configured the SQLnet.ora, we've configured the listener. We need to restart the listener so that it picks up those changes. That's already been done. So if we check the status of the listener, we'll see that it's ready. It has registered port 2484 using TCPS. So it's listening and available for encrypted connections using SSL. So that's the Oracle database side set up. The next set of changes need to be made on the Remedy server. The Java instance that we're using to run Remedy needs to have that certificate file that we exported from the database side imported into its CA certs file. I'm using JRE 1.8 release 131, and in the lib security directory there exists a CA certs file by default which contains the public certificates that Java ships with. So we've added the certificate to that file using the keytool command, import cert, and we can also then list the contents of the file just to show that the certificate is there and available. Finally, we need to enable it within Remedy, which involves changes to the ar.cfg file. So this is the configuration as it was for the native encryption. There were no changes made on this side other than when we demonstrated the custom con props. We talked earlier about the JDBC connection string and how the values that are used are derived from the server port and the DB name, DB user within the ARCFG. The format that's required for SSL connections to Oracle is slightly different. We again need to specify TCPS, so we can't do that using the existing configuration parameters, which is why in Service Pack 2 this new Oracle JDBC URL option was added, which allows you to provide a fully qualified connection string. If that's present, it will override and be used in preference to the derived one from the previous connections. So to enable the use of SSL in this case, we simply need to uncomment the Oracle JDBC URL directive. We've already configured it. It's using TCPS. The host is the same one we're using above, different port number, but that's the only change that we're going to make. These other settings will now be ignored because this one is present. So we'll save that, and we need to go ahead and restart the remedy server so that it picks up the changes. And once that's done, we'll take another look in Wireshark and see what the state of the connections is. While we wait for the database to start, we can take a look at Wireshark at the information that's traveling backwards and forwards as the cache is prepared and loaded on the AR server side. The first thing to notice is the destination port for connections to and from the database. We're now using port 2484 on the Oracle server side, which is what we configured to use for SSL. So if we take a look at the packet contents, again, they look very similar to the case when the native encryption was enabled. They no longer contain any recognizable, readable, legible text. They're all apparently random characters. So we can see that the correct port numbers being used, the SSL enabled port, and the packet contents seem to show that encryption is being applied as we would expect. We'll wait for the server to start completely, and then we'll just log in and perform the same tests with the group form just to verify that the data looks as expected again. Okay, so the remedy server has started, I believe, and let's see if we can log in. Yes. So let's go and restart packet capture. And we still see that all of the data is encrypted. No more select statements or plain English text. So that's Oracle with SSL encryption enabled and configured. And in the next section, we'll take a look at doing the same with Microsoft SQL Server. The final video covers Microsoft SQL Server with SSL. The process is very similar to that used for Oracle in that the certificate needs to be added to both the database and AR servers, as well as configuration changes to both pieces of software. In this case, it's the DB custom comprops that is required to pass the option that tells the JDBC driver to create an encrypted connection. In the third use case we're going to look at, we're going to be enabling SSL for use with Microsoft SQL Server. So I've reconfigured the test system now to use the SQL Server database, and if we take a look at the server information, we can now see we're using SQL Server. Again, we can just do a quick check by capturing some new data using Wireshark, using the same set of steps we did with the Oracle database. Go and have a look at the groups, select a few records and take a look at the data. There we go. We can see straight away that the information is recognizable as plain text. A little bit different to the Oracle case, the structure of the packets, but nonetheless it's clear that we're not using any form of encryption between the remedy server and the database at the moment. So the configuration of SSL with SQL Server is somewhat similar to the case with Oracle in that we need to obtain a certificate, we need to configure the database to use that certificate, and then we need to import that certificate for Java to use on the remedy server before finally configuring the remedy server to enable its use. Rather than using the command line tools as we did with Oracle, I'm going to use IIS here to create a self-signed test certificate. It's one of the features that's available if you happen to have that bit of software installed. Within the IIS console, you can go to Server Certificates and right-click, and you can very easily create a self-signed certificate. That's already been done in this case. The next thing that we need to do is make that certificate available to the SQL Server. So that's done using the MMC, the Management Console, and the certificate snap-in. Again, if you want the full details and the full steps involved, there's a Trending in Support article that goes through in more detail. But it's basically a case of setting up the certificate and making sure that it's enabled for use by the right people. So it's been set up and configured using MMC, and then finally on the SQL Server side we need to configure it actually within SQL itself. So we use the SQL Server Configuration Manager, the protocols for the SQL Server, have a look at the properties, certificate, and here we should have, if the previous steps have been followed correctly, we have the certificate available. We can apply that, and as we had with in the first instance with Oracle's Native Encryption, we do get the choice to force encryption or just the default of just accept it, but we'll leave that at no at the moment. So we have the choice, we can configure that on the remedy side whether or not we want to use it. So the certificate's configured, it's not expiring for plenty of time, so we need to restart the SQL Server service before we can use that. So we'll restart that. While that's happening, we'll switch over to the remedy machine and make sure that the certificate has been imported and is available for remedy to use. So the SQL Server has been restarted, and if we switch back to the remedy system, we can see that remedy is working as expected. So the next thing that we need to do is to take the certificate that was added on the SQL Server side, and as we did the Oracle database, import it into the Java CA certs file. Again, I've already copied across the file, in this case to sql.cert, and we're going to use the keytool command again, import cert file, give it an alias of SQL cert, and import it into the CA certs database. Again, that's been done, and if we do a list of the certificate, we'll see that it's there. So now we actually have two. We've got the DB cert for Oracle and the SQL cert for MS SQL. So that's the database side and the remedy Java instance complete. So again, we now need to make a change in the ARCFG file to enable its use. Now, the JDBC connection string format for SQL Server doesn't require any changes to enable the use of SSL. However, we do need to pass a new parameter, a different configuration option, to the JDBC driver. And again, we're going to make use of the DB custom comprops setting. So the option that we need to send is encrypt equals true. We've uncommented that. Let's save the file, and we need to restart the remedy server. So let's stop it. We'll clear out all the log files and then go ahead and restart. And we'll see the files start to appear. So we'll just hold on for a moment until the server is back. Okay, so I believe the service is running. Let's just go and double check. Yep, so again we can go to the groups form, and we will, before we do that, let's restart the packet capture. do our search, select a few records, and then go back and have a look what we can see. Now, again, we can see straight away in the type of information, the network information packet data, that there's some kind of TLS, SSL traffic going backwards and forwards. And if we look at the packet contents, we should recognize the type of text that we've seen in the previous examples, showing that it is indeed encrypted information. Now, if we scroll through the different packets, you'll notice there are no examples of plain text, as we saw earlier on before we enabled the encryption option. So that concludes the practical side of the webinar. We've had a look at the three different options: the Oracle's native encryption, SSL with Oracle, and now MS SQL with Oracle. MS SQL with SQL, sorry. So we can see that it's fairly straightforward, certainly in the case where you're using self-signed test certificates, to set up and enable the encryption between the systems. Again, there are, for each one of the use cases, there's a trending in support blog article which goes through the full setup and includes details of the commands that you use and screenshots if you want to have a go at setting this up in your own test environments. These are links to the trending in support articles that were referenced in the setup videos. These have more details and screenshots of the steps followed, along with links to additional sources of information. Also included here are links to specific details about how encryption works with the JDBC drivers for each database. That concludes this webinar. I hope you will find the information provided useful and that you are encouraged to go ahead and test these configurations in your own environments. Whichever database you're using, you already have the software available to support encrypted connections. It just needs to be enabled before you can evaluate it for use within your organization. Consider it the next step on the road to a more security-conscious future. If you would like to get in touch with BMC to discuss this webinar or any other remedy-related matters, you will find many of the support team active in the communities and on other social media. You can also contact us via the web, by telephone or email. If you're looking for help with a problem, don't forget the search feature on the support website. This indexes a large number of knowledge base articles along with the content from the communities. Thank you for watching this Connect with Remedy webinar. Please check the BMC website for archives of previous webinars and a schedule of those that are coming soon.